Welcome to qnawire.
In this problem, we have a uniform rod that has a mass of 0.0300 kilograms and a length of 0.4 meters. Then we have two of these rings on this rod that can slide, and they each weigh 0.0200 kilograms, or have a mass. Sorry, not the weight, mass. They initially start off at a distance 0.05 meters from the axis of rotation, which is in the center of this rod. The rod's initially spinning at 48 RPM, which is 5.03 radians per second. Now, the mass moment of the rod, so a uniform rod spinning about its center, is 1/12 the mass of the rod times the length of the rod squared. And then we add these two, and we're going to call these, say these are point masses, and they add 2m2 times d squared, the distance from the center, the axis of rotation is d, to this mass moment for the total system. And now they say that these things, basically start to fly off, and they ask us what is the speed if there's no torque, if there's no torque applied to this, what is the speed of that this thing is rotating when these rings get to the end. So the mass moment, the moment of inertia, is going to change then. And so when these things get to the end, d becomes L. So this is in the end state mass moment. And so this is conservation of angular momentum because we have no torque acting about this point, and this is in a horizontal plane, so the gravity isn't affecting the rotation. Now let's see here. So then we have the initial angular momentum and the final angular momentum, and they have to be equal to one another, which says that the angular velocity in the second state is the mass moment in the first state divided by the mass moment in the second state times the angular velocity in the first state. So we can throw those all in here, and we wind up with a value for the angular velocity when these rings get to the end of this rod of 1.26 radians per second, or about 12 RPM. So about a quarter of what it was. So it slowed down to about a quarter of what it was because the mass moment has increased by about a factor of 4. Now let's see here. They ask us what happens when these rings, just after they slip off of the rod, and really nothing changes there. There's no more force between the rings and the rod, but at that instant, the rings still have the same velocity as they did, just before they came off. So their angular momentum is the same, and so then the rod would have the same angular momentum. So basically, nothing changes then just after the rings leave the rod. The angular velocity of the rod will still be 12 RPM.